Hello students, welcome back. So students, we have been discussing the chapter rotational motion. Now let us start with the next module of the chapter rotational motion. This module is called as numericals based on principle of perpendicular and parallel axis. Okay, both the theorems we are going to discuss the numericals. It's an interesting and very important module. So are you geared up? Can I start? Fine, let us move on. Let us take a look at the first question. It's a simple one. Let me read the question. Consider a rotating rigid body which is placed in XY plane. Its moment of inertia about x-axis is 20 kilogram meter square and about y-axis is 10 kilogram meter square. Calculate its moment of inertia about z-axis. Okay students. So, we have been following a procedure. What's that? Yes, step by step. What's the first step? First step is you have to write down what are the given quantities. Students, question is on your screen. Okay, fine, no problem. What is the first given quantity? Yes, first given quantity, very good. Here, moment of inertia about x-axis is 20 kilogram meter square. So, Ix is given as 20, fine. Next given quantity, yes, moment of inertia about y-axis is 10 kilogram meter square. Iy is given as 10. Alright students, any other given quantity? No, fine. Next step, good. Next step is we need to write down what quantity we need to find out, So what we need to find out, student? Yes, calculate its moment of inertia about z-axis. So we need to find out what is Iz. Third step, your favorite, formulas. So which formula I can use? Very good. I can use the theorem of perpendicular axis. So I can write Iz is equal to Ix plus Iy according to theorem of perpendicular axis. I can use this formula and calculate Iz. Very simple. Yes or no? Fine. Let me carry this forward and let me move on to solution. Students, it's a very simple problem. I'm very sure by now you must have calculated. First, Iz is Ix plus Iy. We know what is Ix and Iy. Yes or no? Ix is given as 20. Iy is given as 10. So Iz will be 20 plus 10. What is 20 plus 10? 20 plus 10 is 30 kilogram meter square. Simple problem, students. Alright. So can we move on to the next one? Fine. Next question. This is an interesting one. Okay, let me read the question. A uniform disc of mass 5 kg has a radius of 0.5 meter. Calculate its moment of inertia about an axis passing through its circumference and perpendicular to its plane. Okay, students. First, step by step, first one. Very good. We need to write down what are the given quantities. Alright, students. So, what is the first given quantity? Yes, mass 5 kg. So the mass of the disc is given as 5 kg. Yes, what is the second one? Yes, very good. Radius is 0.5 meter. So R is 0.5 meter. Third, any other given quantity, students? No, we just have these two given quantities. Alright, next step is we need to write down which quantity we need to find. Okay, now what we need to find, students? Yes, very good. We need to find out the moment of inertia about an axis passing through its circumference and perpendicular to its plane. To understand this, let me draw the diagram. Alright, a uniform disc. Alright, point C is the center of the disc and radius of the disc is given as 0.5 meter. Now let me consider an axis passing through the center and perpendicular to the plane. And if the disc rotates about this axis, ZZ dash, then its moment of inertia will be IC. Now where I have to take the point? Now let me consider one more point on the circumference and let me draw an axis passing through the circumference of the disc and perpendicular to the plane of the disc. Now this axis is your XX dash, and if the disc rotates about XX dash, then its moment of inertia is I naught. What we need to calculate? Yes, see the question, circumference. So we need to calculate what is I naught. Okay students. Next step is your favorite one. Yes, formulas. Which formula can I use here? See the diagram. Yes, two parallel axes. So I can go on for parallel axis theorem. Now hold on. Before applying parallel axis theorem, I know what is IC. Yes, IC is mr square by 2, moment of inertia of a disc about an axis passing through its center and perpendicular to its plane is mr square by 2. And then I can write the parallel axis. Parallel axis is I naught is IC plus mh square. Hold on. What is h? See the diagram. H is the distance between the two parallel axes. Now see there, R is 0.5 and H is the distance between the two axes. So we can say H is also 0.5. Very simple. Okay students, now let us move on to the solution. Let's carry this forward and let us start with the solution. Now students, for solution first, which formula I have to use? I naught is IC plus mh square. I'm writing it over there. So I naught is equal to, what is IC? IC is given as mr square by 2, or it is half mr square plus mh square. Now what is h? H and r both are same. So then I can write mh square is nothing but mr square. So I naught is half mr square plus mr square, which is 3 by 2 mr square. Now students, I naught is 3 by 2 into m and r is given. See the question. M is given as 5 kg and what is r? R is 0.5. So I naught will be 3 by 2 into 5 into 0.5 square. On solving, you will get I naught is 3 by 2 into 5 into 0.25, which is nothing but 3.75 upon 2. If you divide this, you will get I naught as 1.875 kilogram meter square. Very simple problem. Is that clear, students? Numericals are very easy. You can easily do it. So students, keep revising and I'll meet you up with the next module. Keep this in your mind. Nobody can stop you. You can do it. Rise and shine.